Chapter 5, Section 2, Properties of Rational Exponents and Radicals. Let's begin. Okay, I'll give you a second to write the title. I'm sorry.
You know what, Coach Matt? Watch this. I'm going to try on this chapter.
Hey, you're not supposed to be talking. You're supposed to raise your hand if you have a question.
Watch.
Okay. So I want you to work with each other on this first slide. Let A and B be real numbers. Use the properties of exponents to complete each statement. Then match each completed statement with the property it illustrates. So, I want you to try to remember these things from Algebra 1. Try. I said try. Work with a partner. Work with people around you. Or work by yourself if you want. You're going to try to give me the correct answer. And then you're going to try to match the correct property with that answer. Question?
What is that little line for the, what's the name?
That's a does not equal.
Yeah. So it's a line going through equal sign, so that means does not equal. So A does not equal 0.
Okay, there.
Okay.
Could have just asked the math problem.
Okay. So letter E, B does not equal 0. F, A does not equal 0. G, A does not equal 0. Yes?
Do you have to guess or can we use something?
Oh yeah, you can use the book if you want. Sure.
I'm trying to work.
Go for it.
That's not hard.
So, I'm going to give you a little bit of time, maybe 5-ish minutes to work with some people around you to go through A through G. And then we're going to go over it together. Okay, let's go over these real quick. Okay, letter A. A to the negative second power. What would that equal?
D.
Well, no, it wouldn't equal D. What is it equal to?
D. Not 0.
Not zero.
Does anyone know how to handle a negative exponent?
No.
Good thing we're covering this in class. Okay, to handle a negative exponent, I change its position in the fraction. So this is technically over 1. Okay? To make it a positive exponent, it's in the numerator right now. I'm going to put it in the denominator, and that exponent's going to become positive. So it equals 1 over A squared. So anytime you have a negative exponent, you just change its position in the fraction. You're not flipping the whole fraction. It looks like we did here.
That's exactly.
We're not flipping the fraction though, because there's a 1 up here as well, next to my A to the negative second power. And there's still a 1 down here when I flip, or when I move its position in the fraction.
So you did flip it.
No, I didn't. This A to the negative second power just moved down. That 1 up here stayed up here. That 1 down here stayed down here. So if I have 3A to the negative second,
That was a horrible.
that would be 3 over A squared. You just move the thing that has the negative exponent's position in the fraction. Okay? Does that make sense? So if it's 3A to the negative second, just the A to the negative second moves downstairs. We okay with that? Yep, the exponent becomes positive when you change its position in the fraction. So what do you think this property is called?
Negative exponent.
Very good. D. Negative exponent. It's our negative exponent property. Any questions on that? Okay. Letter B. I have A, B to the 4th power.
I can say this one too.
What is my answer though? Don't tell me the property. I want the answer.
It's B.
Oh.
It's B.
Sorry.
What does A, B to the 4th power equal?
100.
A, B to the 4th.
A, B, C.
Let's think about it real quick.
If someone said,
Let's say I have...
Oh, A, B times A, B times A, B times
Yeah. Very good. Sorry if I didn't hear you. I apologize. If I have 5 to the 4th, I could write that out as 5 times 5 times 5 times 5, where I have 4 5s, correct?
A. Yeah.
yes.
So, this is 4 ABs multiplied out. AB times AB times AB times AB. Okay? How many A's do I have there?
4.
4. So that would be A to the 4th power. How many B's do I have there?
4.
So that would be B to the 4th power. So AB to the 4th becomes A to the 4th, B to the 4th. Another way to look at it, I've got these things in here. I can multiply well, first off, A is to the 1st power in the parentheses, correct? B is to the 1st power in the parentheses. I can multiply every exponent in the parentheses by this exponent outside of the parentheses. So what's 4 times 1? 4. 4 times 1? 4. So I get a to the fourth, b to the fourth. Does that make sense? Yes.
So if it was a to the second power, would you multiply it 4 times 2?
Yep. So it'd be a to the 8th, right? 2 times 4 is 8. Does that make sense?
Yes.
Okay. So what is this property?
Hey, wait, I mean, yeah, B.
Not B.
C.
C. It's power of a product. I've got a product inside my parentheses. My product is raised to a power. So it's power of a product. So I've used C, I've used D. Does that make sense why it's power of a product?
I guess so.
Okay. Letter C. Kind of based on letter B. 5a cubed raised to the 4th power. How could I expand that out? A3 times a to the 3rd times a to the 3rd times a to the 3rd. 4a to the 3rd is all being multiplied, right? How would I expand a to the 3rd each time?
You're really gonna do that? That many times?
It'd be how many a's each time?
A, A, A.
3, right?
Yeah.
So it'd be 3 a's, a times a times a, times a times a times a, times a times a times a, times a times a times a. So how many a's would I have total?
Like
12.
12. Right?
3, 6, 9.
3, 6, 9, 12.
15.
Did anyone see a shortcut here? Multiplying, right? Got a power raised to a power. I can multiply every exponent in the parentheses by the exponent outside the parentheses. What's 3 times 4? 12. So that'd be a to the 12th. Does that make sense? Is that okay? So, what would this property be? B. Power of a power. We've got a power raised to another power. Questions on A through C so far?
No.
Kind of okay.
D.
Okay, letter D. I've got a to the 3rd times a to the 4th. What would my answer be here? Not a to the 12th. Let's think about it here. If I expanded a to the 3rd out, what would that be?
A times A times A.
A times a times a times a to the 4th. How would I expand that in? So that'd be 4 a's, right?
Yeah.
So how many a's do I have total here being multiplied now?
7.
So that'd be a to the 7th. So do we see a shortcut here? If I'm multiplying a power times a power. What's the shortcut? Add them. If I'm multiplying things with the same base, I can add their exponents. So what's 3 plus 4? 7. So a to the 7th. Does that make sense?
You could have just told us that.
So what's my property here?
Products of powers.
Product of powers. I've got two powers being multiplied together. So product of powers. Questions on D? Okay, letter E. I have A over B to the 3rd power. A over B to the 3rd power. How would I expand this out?
A divided by B. Or A over B.
Now, who went around all that?
Just A over B times each other. There's 3 of them, right? So, how many A's do I have upstairs?
Trace.
3. How many B's do I have downstairs?
Trace.
3. So that'd become A to the 3rd over B to the 3rd. Similarly, to letter
It's
B.
not supposed to take that long, but she said if you could call her.
You just interrupted us.
No, don't call her now. She's fine.
Okay. Okay, so similar to letter B, every exponent in the parentheses can be multiplied by the exponent outside the parentheses. What exponent does A have inside the parentheses?
1.
1. What exponent does B have?
1.
What's 3 times 1?
1.
3, A to the 3rd. What's 3 times 1? B to the 3rd. Does that make sense?
You keep making us do all of this work.
Shh, please quit. Please quit. So, what would the property be here for letter E?
G.
H.
No,
Is
it's
it?
not E.
Probably
I
one
think
would
it's
be
If
B.
I have a division problem raised to a power.
I put G.
G.
Power of a quotient, G.
Yeah.
Wait, we said that. Why'd you say no?
Why did you say
You said F first.
Oh, then we
Like
corrected
4
it.
examples said D.
You guys were just guessing all the ones that were left.
Well, duh.
Well, it's kind of
So,
That's how it works.
so I've got a quotient, A divided by B, being raised to a power, so it's a power of a quotient.
now
Okay.
process of elimination.
Yeah, this one should be pretty easy for the next two, for the properties at least.
Oh.
Okay, letter F. We've got a to the sixth over a squared. Okay? How would I expand a to the sixth up top?
A times A times A times A times A times A.
1, 2, 3, 4, 5, 6. How would I expand a squared?
A times A.
A times a. Okay? If I have, say I have 10 over 5. What's 10 divided by 5?
2.
2, okay.
2 or 1.
10 can be written as 5 times 2, correct? What would happen with my 5s there?
That's a great question.
They cancel each other out. So I get 2, right? What's 10 divided by 5? 2. That's how that works. Okay? So if I have one thing up top, but I have that thing down in the bottom as well, I can cancel it out. So here,
4.
I can cancel an A up top with an A downstairs. And I can cancel another A up top with another A downstairs. Can I cancel any more A's? No, because all the ones are out of the bottom. So how many A's am I left with up top here?
4.
So it'd be A to the fourth.
Why don't you just do 6 minus 6?
Hold on, shh, I'm getting there. I'm showing you what's going on in the background for our little shortcuts. Okay? Does that make sense? What we just did there.
Ah, yeah.
So, what is our shortcut here?
Subtract.
6.
Subtract. So, up here, we were multiplying something with the same base. We added our exponents. Down here, we're dividing something with the same base. We can subtract our exponents. What's 6 minus 2? A to the fourth power.
Why wouldn't you divide them?
Because of what I just showed you.
Oh,
Does that make sense?
yeah.
So you're still technically dividing. Our shortcut just involves subtracting the 6 and the 2.
Okay.
Okay? Questions on F? No. What property would this be?
Quotient of powers.
Quotient of powers.
You're
We've got two powers being divided. It's a quotient problem with powers in it. So it's quotient of powers.
I don't think it's 1.
You okay with that?
G.
Just okay so far, better than we expected.
Last one is E.
Okay, last one. A to the 0 power. What is it? Don't say 0.
It's E.
It's not 0.
It's A.
No,
It's just A because
It's not A.
Yeah, it
Then
is.
it's 0.
Is it the sign? Is it the equal sign?
Oh my.
Anything to the 0 power.
Oh my god.
1.
Is it so?
I was right.
Anything to the 0 power is 1. If I have
A.
12,543,251 to the 0 power, the answer is 1. Okay?
Okay.
That is our 0 exponent property. Okay?
You know, I don't like that.
Sorry.
There's that kind of counters itself. It's like anything times 0 is 0.
I'm not multiplying this by 0, am I?
You kind of are.
No, I'm not.
So why is it
For an exponent, if I have 5 squared,
Yeah.
I don't do 5 times 2, do I?
No, but you're 5 it by 5.
Yeah, 5 times 5.
so how is it?
2
Yeah,
times.
fine.
I don't have anything being multiplied here, so it's just 1.
I ain't got
I don't know about that.
Okay.
What if we just,
There any questions about any of our properties here?
No.
Anything to the 0 power is 1. Okay? Can I move on?
Yes.
you want to just be 8?
Okay. Working with your partners using the properties we just learned about so that you can apply the properties of integer exponents to rational exponents by simplifying each expression. Use a calculator to check your answers. So I'm going to give you a little more time, about 5 more minutes, to work on these with your partners. Okay, here we go.
I'm confused.
Say it again. Okay, letter A.
Let's do one.
We're multiplying two things that have the same base, right? What are the base? What's the base here? 5. Do they both have a base of 5? Yes. What property can I use here if I'm multiplying something with the same base? Product of powers property, right? What did I do when I was multiplying two things with the same base? What did I do with the exponents?
Yeah,
I added them, right? So over here, what am I adding?
2 and 4.
2/3 plus 4/3. I'm adding those exponents. Right?
Yeah, it equals 1.
What's 2 plus 4? 6. Do I add the denominators? No, it stays the same. You got to have a common denominator to add or subtract, right?
Yeah.
So these already had a common denominator, so I could add them. Add the numerators, keep the denominator the same. So, this is 5. What's 6 divided by 3? To the second power. What's 5 squared? 25.
That's the answer.
25 is your answer,
Why
yep.
did you decide to put fractions as the exponent?
It's still the same concept. You're still adding the exponents of something that you're multiplying with the same base.
Taught us.
That is the same thing I just taught you. Same exact thing.
Those are all whole numbers.
That's okay. It's still a number. They're all real numbers. Fractions are real numbers. Whole numbers are real numbers. They're all real numbers. So it is the same thing.
Why don't you put in the example?
I did.
Can you
Can
go
you
back?
go back?
Letter D is the example.
Are those fractions?
Why isn't it not
Indeed.
25 to the second power?
Say it again.
Why is it not 25 to the second
That is
power?
not.
Because remember, on this property over here, we're not multiplying the bases. We're adding the exponents. And the base stays the same.
5 to the second.
Yeah, 5 to the second, which is 25.
So what's 25 for?
Because 5 squared is 25.
So which one's the answer?
I would write this down.
Yo.
Both of that?
What?
I want to see that you know that you're adding the exponents to get 2. And then I want you to show me that you know 5 squared equals 25.
Oh, I get what you said.
Wait.
You just make that a lot more complicated.
No, I didn't. You're overthinking it.
Okay, can you like basically read that all that again?
If you're multiplying something with the same base,
Okay.
So the
you
base
keep.
doesn't
Shh,
change.
shh, shh. I'm trying to explain. Multiplying something with the same base, you keep the base, add the exponents. And then if you have a number raised to an exponent, you can evaluate it. Now, if we had a variable there, we would have just left it as like x squared.
I'm confused on how it's third.
What's 6 divided by 3?
What's
So,
divided by three?
B, it would just.
2.
There you go. That's how I got 5 squared.
So where you get the 5 from 2 5? Yes.
Huh?
You get the 5 from the 2.
Yeah, I kept the best. I can't talk. Kept the base the same.
Okay, but what if the bases aren't going to be the same?
Then you can't add the exponents.
So then. You gotta break it down heads and ways. You know what I mean?
Huh?
You gotta break it down heads and ways.
I did. If they have the same base and they're being multiplied, you can add the exponents.
Okay.
If they don't have the same base and they're being multiplied, you cannot add the exponents. So let's say I had 6 squared times 3 squared.
No, go ahead and do a fraction. Do a fraction.
So it's just 3.
2 fractions.
So 6 to the 1/2 times 3 to the 3/2. Do they have the same base?
Yeah.
100.
No, they got the same. What's it called? No.
Same base. Not same denominator in the exponent.
No.
Same base.
No, they don't.
No, they don't. So can I add the fractions? Add the exponents? No. So I just have to evaluate 6 to the 1/2 power, 3 to the 3/2 power, and then multiply those two numbers that I get.
I think I'm making this harder than
I think you are. We're ready to start going through these? Okay.
Yeah.
Letter B. Multiplying two things, do they have the same base? Yeah, so if they have the same base and they're being multiplied, what can I do with the exponents?
Just
Add them. So I have 1/5 plus 4/5. Do we have a common denominator? Yeah. So I can add the numerators. What's 1 plus 4? 5. What's my denominator? 5. What's 5 divided by 5? 1. So 3 to the 1/5 power times 3 to the 4/5 power is 3 to the what power? First power. What's 3 to the first power? 3. Questions there? Same concept as letter A.
Okay, Coach Alistair.
Look at, she's getting sassy again. We okay with B? Letter C.
I figured it out.
We're no longer multiplying powers, are we? But we have a power raised to a power. How do I handle a power raised to a power, like letter C?
You multiply the exponent inside the parentheses and outside.
Very good. Take every exponent in the set of parentheses, multiply it by the exponent outside the parentheses. So I'm doing what times what?
2/3 times 3.
2/3 times 3.
2.
What is 2/3 times 3?
2.
2. So I get 4 to the second power. Does everyone see how I get 4 squared? 2/3 times 3 gives me 2. So that's 4 to the second power. What is 4 squared? 16. We okay with letter C? Kind of getting the hang of it now. Hopefully.
Oh, no. I wrote the wrong one.
I didn't see that one.
So we multiplied 2/3 and 3 because I've got a power raised to a power, just like letter C here. So I multiply all the exponents inside the parentheses by the exponent outside the parentheses. So 2/3 times 3 gives me 2. So 4 to the second power is 16. Okay? Letter D is similar to letter C. I have 10 to the 1/2 to the 4th power. What do I need to do here? Got a power raised to a power. What do I do with those exponents? Multiply them. So I've got 1/2 times 4. What's half of 4? 2. So I get 10 to the second power, which is 100. Any questions on letter D? Everyone okay with that?
Don't change it.
Everyone okay with that?
Yeah.
Letter E. 8 to the 5/2 power over 8 to the 1/2 power. It's a different type of problem now. Do my numerator and denominator have the same base? Yeah, what's my base here? 8. If I'm dividing something with the same base, what do I do with the exponents? Subtract them. So what numbers am I subtracting here?
5/2 minus 1/2.
5/2 minus 1/2. In order to add or subtract fractions, I need a common denominator. Do I already have a common denominator?
Yeah.
Yeah, so I don't need to do anything here to change them. What do I do with my numerators? Subtract them. What's 5 minus 1? 4. What's my denominator? It stays the same, doesn't it? So, what's 4 divided by 2? 2. So if I have 8 to the 5/2 divided by 8 to the 1/2, I get 8 to the second power, which is
91. Wait, 64.
64. And there's letter E. Are we okay with this so far? Questions on E? And the last one, letter F. I have 7 to the 2/3 power over 7 to the 5/3 power. Do my numerator and denominator have the same base? What's the base? 7. So what two numbers am I subtracting here? It's a little tricky here. 2/3 minus 5/3. Whenever we're using our division or quotient of powers property, we always do top exponent minus bottom exponent. Does that make sense? Top minus bottom. So here it's 2/3 minus 5/3. Do I have the same denominator? Yeah. So what's 2 minus 5? -3 over 3, which is -1. So when I'm dividing 7 to the 2/3 divided by 7 to the 5/3, I get 7 to the negative first. Uh-oh. That negative exponent property is coming into play now. For it to be in its simplest form, I don't want any negative exponents. So, how do I handle a negative exponent now?
Radical.
Flip it.
Don't flip it.
Oh.
Do not flip it.
We'll bring it down.
Change its position in the fraction, right? So this is 7 to the negative first over 1. Right? So if I just move the 7 to the negative first downstairs, I get 1 times 7 to the negative first, right? Or to the first. 1 times 7 to the first. What's 7 to the first? And then what would be left upstairs? 1, right? So, and then what is 7 to the first power? 7. What's 1 times 7? So I get 1 over 7. Everyone got that? If you have a negative exponent, change its position in the fraction. Just the thing that contains the negative exponent. You don't just flip the fraction. It looks like you do that if there's a 1 involved in my denominator and nothing else up top. It looks like you flip it, but you're not flipping it. You're just changing that thing that has a negative exponent, changing its position in the fraction. Okay? Any questions on our exploration 2 example? Can I move on? All right. Now we're going to use properties of exponents to write each expression as a single radical. Then evaluate each expression. Use a calculator to check your answers. I'll give you a little bit of time to work with your partners. Okay, this is where we'll pick up tomorrow. We'll go over these. Start right off the bat tomorrow. We do need to move rather quickly tomorrow on the notes. So be prepared to come and not discuss as much as we discussed today. And be as sassy as we were today. And get ready to get going right when we get to class. We good?